Okay, the next chapter is chapter 6, and it's on probability. Probability is very interesting, well, for maybe 5 minutes or so, and then it's not. The basic idea is I put a problem from your book in here. It's example 6.2. If you turn to page 171 of your book, you can see on figure 6.4, they actually draw the probability in the normal curve there. Remember, the idea is if you get a z-score of 0, that means 50% of the group did better than you. If you add up the 34, the 13, and the 2.5, you get 50 there. If you get a z-score of +1, that means you did better than 84%. That's the 50 to 0, then the 34 from that. And if you get a z-score of +2, that means you did better than 97.5%. So the higher z-score, the better. So the question that chapter 6 gets into is the question of example 6.2, SAT scores normal, mean of 500, standard D of 100. And the question they ask is, given this information, what is the probability of randomly selecting a person who has an SAT score greater than 700? So the math on this is actually not terribly difficult. If you want to figure out what is the probability of getting someone higher than a score of 700, what you simply need to do is do the z-score formula. You get your z-score, and then you figure out what area is above that particular z-score that particular z-score. So if you take those numbers and get a z-score, the x is 700, the mu is 500, the sigma is 100. Can you do the z-score computation? Hopefully what you get with the z-score computation is a z-score of +2. If you turn the page and see that, the idea is 1, 2, and 3 show the steps to get that result with the z-score of 2. And then part 4 is what proportion gets better than that? What is the probability of getting better than that? You have to figure out the z-score, or the probability of getting a score greater than 2. If you turn to the back of the book, once again, page 701, you get the z-score of 2. The idea is what proportion is in the tail there, and it's about 2.28%. So the probability of randomly selecting somebody who has a z-score or gets a score of 700 or above, the probability of that is only about 2.5%. You can see the figure 6.5 drawing that, and that's how we do z-scores and probability. Kind of going through this rather quickly with you because this is not critical information. I do have a homework problem in the back of the chapter there as well. Looks like it's on page 197. It's question 13. What I basically want you to do with question 13, normal distribution, mu of 50, sigma of 12, and basically see if you can figure out what the proportion in the tail is. So do each of those x scores, get a z-score from that, and then use that chart on page 700, 701 to figure out the probability in the tail. It looks like some of the scores are positive scores, so that will be above the mean, and some of them are negative scores, which will be below. So give it your best shot and see what you can do. Thanks, everybody. Bye-bye.